This two-part course is designed to acquaint new and incumbent theater employees with the theory and care of theater motion picture equipment. Specific topics to be addressed are film inspection and splicing, projector head theory of operation and component cleaning, sound head theory of operation and component cleaning, theory of operation and maintenance of the carbon arc lamp house, theory and operation and care of projection lenses, and the proper techniques for threading the film in the projector. Automation in modern theaters has presented a number of problems to the projectionist. The two most important of these being the correct identification of the film's title and the correct part number of a given reel. These problems begin when the film is to be shown on large reels such as these. Showing the film on this type of automated equipment requires the removal of the leaders and tails and splicing together the standard 20-minute reels used for shipping to produce a continuous performance on a single projector. To overcome these identification problems, most commercial projectionists are now leaving a few frames of picture on the leader and tail of each reel. This procedure will allow for proper visual match of the leaders and tails to their corresponding film rolls when the film is being reassembled and readied for transit to the next theater. The art of visual and touch inspection will be your most difficult job to master. You'll need to develop an ability to consistently locate film damage. The inspection the film will receive here will determine the enjoyment level of the patrons who will view the feature this evening. Touch inspection consists of holding the film edges between the thumb and first finger and applying enough pressure to cause a curve in the film with one hand while turning the hand rewinder slowly with the other. Excessive film speed will cause friction and heat on your fingertips. Keep the film speed down to ensure good inspection. You should never touch the body of the film during inspection because it may deface the image. Never use a rag or tissue to clean an oily print, as the debris that becomes lodged between the soft, dull film emulsion and the rag will always scratch the print. Occasionally, you may find what is known as split sprocket holes. This particular type of film damage requires special preparation before the film can be shown. Repairing this type of defect involves the cutting of a V shape on the outside edge of the film, entering into each damaged sprocket hole, thus forming a notch. This notching process will prevent the leading edge of the split from catching and tearing in the projector mechanism during the performance. Should you be faced with multiple splits over a small area of film, you would be well advised to splice out the affected area. Historically, the most commonly used splice in the industry has been the overlap cement type. As the description implies, the two ends of the film are joined together by overlapping. Then they're bonded by a suitable film cement. The most common cement splice used in theaters and film exchanges is made on a benchtop splicer, which is designed to include a sprocket hole in the overlapped area. The area of overlap maintains the 4 sprocket holes per frame on either side of the splice, which is required if the film is to stay in frame when projected. A satisfactory splice demands careful scraping to make sure all the emulsion, binder, and any foreign substances are completely removed. The surface on the film to be joined must also be thoroughly cleaned. If the base surface contains even a slight film of oil, some difficulty may be encountered in obtaining a successful splice. Very often this factor is overlooked, and poor splices are falsely attributed to the particular cement used, to the splicing equipment, or to the film base itself. Sometimes it may be helpful to roughen the base surface slightly when films resist satisfactory splicing. An easier, more effective technique of ensuring a good splice is to apply a very small amount of cement to the base side of the film to be joined, then wipe it off immediately. This initial application of cement acts as a primer coating preliminary to the actual splicing operation, and it aids in obtaining thorough adhesion of the two surfaces. The most common mistakes made while preparing a film for splicing are not removing all of the emulsion from the film base prior to applying the film cement and gouging of the film base with the scraper, which weakens the area of the splice. When the emulsion and binder have been satisfactorily removed, the cement should be applied to the splice area. Enough cement should be used to wet the scraped area, but not so much that it will run outside the splice when the two sections of film are pressed together.
It's important to allow a holding time of at least 1 minute under the uniform pressure created by the splicer clamps.
At the end of the bonding time, the pressure may be released and the finished splice rubbed with a soft cloth held over the finger to help seal the cut ends. It should be emphasized that it is important to bring the two surfaces under pressure as quickly as possible after application of the cement. After a sufficient holding time, the splice may be tested by gently flexing the film. Because a cement splice does not usually attain full strength for several hours, care should be exercised when handling the film if immediate use is contemplated. A well-made splice should not contain any bubbles or hazy areas that indicate an imperfect weld. As you may have guessed by now, splicing is indeed an art that requires practice.
In review, you should always observe the 1 minute drying time of the film cement. Insufficient holding time in the splicer is the prime cause of early weld failure. Never mix old and new film cement, and always keep the cap on the cement bottle tightly closed to prevent the solvent from evaporating. Check the film stock to be joined for cleanliness and keep the splicer clean and free of debris.
Over the past few years, the growing popularity of automated projection systems and more recently, the limited availability of polyester-based films has influenced the emergence of the tape splice. This is a splice in which the film ends are securely fastened together by a very thin, perforated polyester tape with pressure-sensitive adhesive. Although commonly used for many years in the 8mm and 16mm field, the tape splice for 35mm applications was not seriously considered before. The need for multiple splices and the loss of picture frames when making regular overlap cement splices have motivated the popularity of tape splicing.
Tape splicing is accomplished by butting the edges together of the two film ends to be joined. The positioning pins and the cutting bar of the splicers used in exchange theaters are designed to correctly orient the film for a butt tape splice. Each tape splice should be of sufficient strength to prevent it from hinging or collapsing when the splice is flexed.
Once you have cut the film ends at the proper place for an end-step splice, the tape splice can then be applied. The tape should be positioned so its center approximates the center area of the splice and then press it into position. When using the mylar tape method, both sides of the film should be taped to prevent the leading edge of the splice from catching in the projector mechanism and possibly tearing the film, causing an interruption in the performance. After completing the splice, be sure that the soundtrack continues on the same side of the film on both sides of the splice.
Misaligned film edges at the splice joint can sometimes occur. This defect is usually caused by worn splicer components or poor preparation and can only be corrected by remaking the splice.
Using this technique will help stabilize the splice and eliminate possible picture jump as the splice passes through the projector. After the inspection of each reel of film has been accomplished, place it in the electric film rewinder and rewind it back to the beginning. Note the placement of the reels and the direction of film travel. After rewinding, the film should always be stored in appropriate containers while in the projection room. The next area to be discussed is changeover cues. The cue is probably the most single important visual tool to be used by the projectionist to create a smooth performance. Your understanding of their correct placement and use will add markedly to your showmanship abilities and the presentation of a smooth performance.
Timing cues appear at 11 feet and 1 1/2 feet before the end of each reel and are used to obtain the required continuity in the presentation during projector changeover.
The cue marks appear in the upper right-hand corner of the film as you view the picture image as it's seen on the screen. In most cases, cues are put on by a film laboratory and normally appear as a black dot or a black dot with a gold crown surrounding it. But on the older films, you may find the standard scratch cue that has been placed there by a film inspection service or a commercial theater projectionist. In no case should you add your own cue marks or change the existing cues unless necessary for a smooth performance. If there are no cues present, use the grease pencil that's been supplied to you.
Both the startup and changeover cue appear in 4 consecutive frames. Each set has a total viewing time of 1/6 of a second. The cue set that appears at 11 feet before the end of each reel signals the startup of the incoming machine. The cue set that appears 1 1/2 feet before the end of the picture signals the changeover of light and sound from the outgoing projector to the incoming machine.
If existing cues are incorrectly spaced, or if multiple cues are present and detract from the picture content, splice them out during the inspection process and insert the proper cues. This will lessen the confusion for the proper timing of changeovers for yourself and your fellow projectionists, and will remove the visual disturbance for the patron. Again, remember, always use the grease pencil for inserting in-house cue marks. Many theater patrons believe the image on the film moves, when actually there's no such thing as a moving picture. Movies are nothing more than still pictures of closely related action, printed on a long, narrow strip of film and shown one picture at a time in such rapid succession that the image appears as one moving picture. The 2 principal parts of a motion picture projector used to accomplish these rapid successions of pictures are the intermittent mechanism and the shutter. The intermittent mechanism consists of 2 major components. They are the star shaft and its actuating cam. The star is engaged for a quarter turn during each full revolution of the actuating cam. The quarter turn of the star pulls down the film 1 complete frame each time it is actuated. The 2-segment shutter, which is placed between the light source and the film aperture, is synchronized by gears to the intermittent movement. The action of these components cuts off the light beam at precise intervals while the film is being moved downward, and again while the film is being held stationary in the projector. The first segment of the shutter that interrupts the light beam while the film is in motion is known as the pull-down blade, and the second is called the anti-flicker blade. With the action of the intermittent movement, the film is advanced and positioned in front of the picture aperture. Each frame of film is held for an instant in front of the aperture and then pulled away very rapidly. This sequence proceeds at the rate of 24 frames per second. This does not imply that each frame is held on the screen 1/24th of a second. The actual time is about 1/2 of this, where the screen is darkened twice, once while the film is moving downward and again while the picture is being held stationary in front of the light source. 2 loops of film are used, one above and one below the picture channel. Without these loops, the film would not pass the picture aperture intermittently. Also, the lower loop of film must be exactly the right size for proper synchronization of the sound and picture.
The soundtrack signal leads the projected image by 20 frames.
The complete projection system is comprised of 4 distinct parts. They are: 1, the projector mechanism, usually referred to as the projector head. 2, the arc lamp, usually called the lamp house. 3, the sound reproducer, usually referred to as the sound head. And 4, the optical train, which consists of the lenses required to project the picture image. The care and cleaning you give this equipment will be the determining factor in the quality of the presentation. Clean equipment is the cornerstone of good showmanship. The good housekeeping of the projection room and the overall cleanliness of the equipment is a good indicator of the abilities and attitudes of the projectionist staff. We are now going to give you some of the basic operating theory of each of these major components and the maintenance that each is to receive during the servicing period of your workday. In the projector mechanism, the first area to be cleaned is the film trap and door. The door is removed by first moving it to the open position by means of the spring-loaded release lever. When the door reaches the fully open position, the release lever catch will hold it in place. With the door in the open and locked position, it can now be removed by unscrewing the 2 knurled pressure nuts that hold it in the position and then pulling it outward. The film door consists of 3 distinct operating parts. They are 1. The upper pressure pad, 2. The lower pressure pad, and 3. The intermittent pad shoe. The film tension adjustment is used to control picture jump and weave that may occur on the screen due to excessive sprocket hole wear in the print or the accumulation of lubricating wax or other debris in the area of the film trap. The intermittent pad shoe controls the film as it enters and leaves the area of the intermittent sprocket. The upper and lower pressure pads stabilize the film in the picture channel when it is moving and at rest. All film door components should be thoroughly cleaned of dirt and wax buildup that accumulates during projection by using a stiff bristled toothbrush. In no case should any component be cleaned with the equipment running. With the film door clear, the trap can now be removed by loosening the threaded holding pin that holds the trap in place. When the threaded holding pin clears the projector mainframe, it can be removed by pulling it outward. The trap should also be thoroughly cleaned of all debris. Failure to do so may result in screen image unsteadiness during projection. Care must be taken to ensure that the 90-degree angles where the film guides meet the film shoes are thoroughly cleaned. This is the area most overlooked during cleaning and has the most effect on picture steadiness. The lateral guide should also be checked during the cleaning process. Both guides should spin freely, and the guide on the left, as seen from the rear of the trap assembly, should float freely on its supporting shaft. This horizontal floating action allows the guides to accommodate splices and varying film widths.
If the action of the guides appears sluggish, add a small drop of oil to each of the 2 shaft pivots. Whoops, too much. If oiling does not free the action, call for service. Do not attempt to repair the problem yourself, as special tools are required to ensure proper component alignment.
With the film trap components removed, the intermittent sprocket assembly can now be cleaned. Because of its relatively high speed of operation, this area is most likely to suffer from severe accumulation of film debris. This fact, combined with its difficult access for cleaning purposes, makes it the most often neglected point in the mechanism. Demonstrated here are the proper materials and techniques for getting the job done. Note the use of the toothbrush and Q-tips. The sprocket position can be changed by using the motor shaft knob located on the front of the sound head. Turning the framing adjustment will change the overall position of the intermittent assembly, making those hard-to-get-at places more accessible. The area of the intermittent sprocket should be thoroughly cleaned prior to every performance. With the film trap components clean, it is now time to install them in the projector. As with most things mechanical, it is often easier to remove a given component than it is to replace it. This is especially true of the film trap. The trap is provided with 2 alignment holes. The alignment holes on the trap mate with their corresponding pins on the mechanism. This mating effect guarantees alignment. The major working component of the film trap area is the fire shutter. Your understanding of its operation is not only important for the correct reinsertion of the film trap, but for the overall safe operation of the projection equipment. When the equipment starts, the fire shutter normally raises clear of the arc light beam. Should the film break above the aperture, it automatically drops into position, activated by the trigger wire. When rethreading following a film break, the fire shutter must be reset by depressing the reset button located on the top left rear of the projector mechanism. For correct alignment and operation of the fire shutter, it is necessary to raise the fire shutter clear of its rest pin located on the base of the film trap by using its reset button. Failure to raise the fire shutter prior to film trap insertion will result in it being jammed in the closed position, preventing it from raising clear of the arc light beam when the projector is started. With the fire shutter clear of the operating area, you will find that the dowel pin alignment holes discussed earlier make for an easy installation. Avoid over-tightening of the holding pin because the heating and cooling of the metal surrounding the threads may make its next removal difficult and in extreme cases almost impossible. With the trap in place, the film door can now be reinstalled. The next areas to be cleaned are the sprocket and pad roller assemblies. As in the case of the film trap, this is one of the few places where the film actually makes contact with the mechanism. It is vitally important to keep all of these areas as free of debris as possible.
To clean the sprockets, slowly move them by turning the sound head motor knob while using a stiff bristled toothbrush.
The pad roller, which guides the film around the sprocket, is probably the most difficult component to clean. This is due to its shape, color, and relatively inaccessible position which it occupies within the projector mechanism. This single component is responsible for at least 25% of all print scratches and is caused by debris buildup which has gone undetected by the projectionist. All sprocket and pad roller assemblies should be thoroughly cleaned prior to each performance and more often if needed. Proper lubrication of the projection equipment is vital. High-cost components such as the intermittent movement can be severely damaged for the lack of a few cents worth of oil. Projector head oil levels should be checked daily. The best indicator of sufficient oil in the reservoir is when a full oil stream is seen flowing from the intermittent oil supply tube after the machine has been running for a few minutes. If the flow is intermittent or if bubbles are seen, the oil level is insufficient and new oil should be added. Use only oil that has been clearly marked for use in the projector head. The use of an incorrect oil will damage the mechanism. The next area to be addressed is the care and cleaning of the sound head. Sound is recorded on film as a continuous photographic image along a narrow strip at one side of the film. The narrow strip is called the sound track. There are two types of sound recording impressions recorded on film. Sawtooth or zigzag waves denote a variable area recording, whereas parallel bands varying in space and intensity along the length of the film denote a variable density recording. Unlike the picture, which is produced as a series of images, the sound is recorded and reproduced when the film is traveling at a constant rate of speed. The sound wave images are recorded on the sound track in such a way that the beam of light passing through the sound track will vary as it falls on the solar cell. As this light beam varies, the electrical impulses produced by the solar cell also vary, and it is these impulses built up by the amplifier that are changed into actual sound waves by the loudspeaker. The greater the width of the sound waves on the film, or greater the density of the soundtrack bands, the greater will be the variations in the amount of light reaching the solar cell. The recorded soundtrack determines both the variation in the intensity of the light transmitted to the solar cell and also the rapidity with which these variations of light intensity occur. The variations of light intensity control the volume of electrical impulses to the amplifier. The rapidity of change gives the pitch and tone and thus creates sound, music, or speech. The ability of the projector to reproduce musical pitch is dependent upon the absolute smooth and constant rate of film travel past the point at which the photograph soundtrack is converted back into electrical modulations. A mechanical means, usually a flywheel, is provided for changing the intermittent motion of the film to the steady motion which is necessary for good sound reproduction. The components required to energize and detect these film recordings are 1. The exciter lamp. 2. The lens assembly, which focuses the image of the exciter lamp filament onto the surface of the film soundtrack. And 3. The solar cell, which converts the light impulses into small electrical currents. This illustration shows a cross-section of the operating components to be found in most sound optical trains. The exciter lamp is powered by a direct current source, usually referred to as the exciter supply. A portion of the light generated is captured by the first lens group and focused on a device known as the lens slit, which is similar to the projector aperture plate. The servicing technician, during the alignment procedure, will adjust the relative vertical position of the exciter lamp filament so that it aligns with the exact center of the slit, allowing the maximum amount of light possible to pass through. The slit then shapes the light into the identical light pattern that was used to record the original sound image. The second group of elements focuses the light pattern of the slit onto the surface of the film. The need for good optical alignment is critical for good theater sound. Tolerances below 1/1000th of an inch are common in most sound reproducers. As you may have decided by now, the cleanliness of the sound optical train and its associated components is essential for good theater sound. To properly clean the sound head optical train, use a Q-tip in the moisture of your breath. Clean both the front and rear of the sound lens thoroughly. Then clean the face of the solar cell. Remove the exciter base and wipe the glass surface of the exciter lamp clean, as it is made of crystal and its clarity contributes to the overall performance of the system. With the sound optics clean, the cleanliness and mechanical operation of the sound gate should now be checked. This device guarantees alignment of the film soundtrack with the sound optics. The functioning areas of the sound gate consist of 3 parts. They are 1, the interior film guide, 2, the exterior film guide, and 3, the pad roller. The film guides control the film edges and maintain proper alignment between the film and sound optics. The interior guide floats on its supporting shaft against a small tension spring, which allows the assembly to accommodate varying film widths and splices with minimal disturbance to the soundtrack alignment. The controlling surfaces of both guides should be thoroughly checked for proper mechanical action and cleaned of debris on a daily basis. Never add oil to the lateral guide shaft if its action appears sluggish. The pressure roller assures film tension around the sound drum. This component is needed to stabilize the film speed past the sound optics and should roll freely.